Hello friends, this video on States of Matter part 13 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 12. The question is, why should we study molecular theory of gas? Why this theory came? And the reason is very simple. We see the gas, they behave in a specific way. That is a fact. And the fact is, gas behaves in a specific way. For example, they don't have any shape, they don't have any volume, right? And they follow all these laws we have, gas laws which I told, my Charles law, Boyle's law, Lusick law, and this Avogadro law. So these are something experimental. They have seen that the gas behaves in a specific way. They don't have shape, they don't have volume. If you put in a big jar, it will occupy the space in the big jar, and they mix easily. They mix easily without any external heat or something. So gas behave in a specific way. We read that all these laws we have, Charles law, Boyle's law, and Lusick law, Avogadro law. So gas follows all these laws, and also we have this real or ideal gas laws. So that means experimentally it is found that gas behaves in a specific way. Now the question is, why gas behave in a specific way? So to understand that, scientists have given different law. So it is similar to the laws which we have in the chemical bonding chapter, where we have molecular orbital theory, valence bond theory. So the atoms combine to form molecule. That is a fact. Why they combine? So there are so many laws to understand that. Similarly, gas behaves in this way. This is a fact. To understand this fact, scientist has given laws, and that law is kinetic molecular theory of gas, right? To understand this fact. So if you see in the container, I have these molecules and they all move around like this, correct? They all move around like this. So the assumptions before we start the kinetic theory of gas, we have several assumptions they have made. The first assumption which was made was that gases consist of large number of small, very small particles. And this is something which explains the compressibility of gas. So you see, compressibility of gas is something which is explained by this. B-I-L-I-T-Y. Compressibility of gas is something explained by this. Why? Because it says that it assumes that the gas consists of very small identical particles. See, the particles are identical. But this is wrong actually. We can prove that, we'll show that this assumption is wrong. So this is the first assumption by the kinetic molecular theory of gas. The second assumption says that there is no force of attraction between the particles of the gas at ordinary temperature and pressure. That means this explains why if you put this gas in a big jar, it occupies the whole volume, right? It occupies all the available space. This explains that, but this assumption is also incorrect. We'll show you that. These two assumptions are incorrect. But it says that, it assumes that there is no force of attraction between the particles of the gas. This is true for ideal gas, but not for real gas. Both these assumptions were true for ideal gas, but not for real gas. The third assumption, it says that the particles of the gas are always in constant and random motion. If you see, it assumes that all these particles are in constant random motion. And this explains why there is no shape of gas. There is no shape of gas. This particular assumption explains that. And this is something which is correct for real gas also. The fourth assumption is that particles of the gas move in all possible directions in the straight line. You see, it moves in all possible directions in the straight line. And during this motion, they collide with each other. You see, they collide with each other. And this explains the pressure exerted by gas. Pressure exerted by gas. So if you see, the gas exerts a pressure. When these molecules collide the wall of a container in which the gas exists, it creates pressure. So these are the, we have four more assumptions. These are the first four assumptions of the kinetic molecular theory of gas. Out of these, first two are incorrect for real gas. We'll explain why in the next two slides. And the other two are true for the real gas also. The next set of assumptions for the kinetic theory of gas is collection of the gas is perfectly elastic. And this explains why there is no loss of kinetic energy. No kinetic energy loss. So if the collision is not elastic, what will happen is these molecules after some time will slow down and lose the velocity, and these particles will settle down, right? But this doesn't happen. So this is one assumption that the gas molecules collision is elastic. At any particular time, different particles in the gas have different speed and different kinetic velocity. If you see here also, some of the molecules are going slow, some are going fast. So it says that, this theory assumes that the speed of all these particles are different. They're not same. Correct? And that is why, if you see, and it's very difficult to find each and every molecule's kinetic energy. First thing, it is difficult to spot the molecules itself because they are so small and there are so many numbers. In a small jar itself, you will find some billions and trillions of molecules. So it's difficult to spot itself. Calculating velocity of each and every molecule is all the more difficult. So we talk about the average kinetic energy. We talk about the average kinetic energy of molecules because there's so many molecules and there are different velocities. It's almost impossible to calculate the velocities of these molecules, at least at this point of time. Maybe the science may advance in future and they'll be able to have some ways to find the speed of all the molecules. But currently there is no way to find the speed of all the molecules in a big container. So we talk about the average kinetic energy of the gas, and this is directly proportional to the kinetic energy, that is right, and this is proportional to absolute temperature. That says that higher the speed of molecules, the higher will be the temperature. So if you increase the temperature here, these molecules will move at a higher speed. That's what this molecular theory assumes, that if you increase the temperature, these molecules will move at higher speed. Correct? So these are 7 assumptions we have for this molecular theory of gases. Out of this, the first 2 assumptions are incorrect. We'll explain why. And the other 5 are correct for real gas also. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.